by acknowledging, oh, sorry, I should tell you that it's our plan today to record the presentation, and we trust that you're happy with that. We won't be recording the Q&As, but we will be recording the presentations. So I want to start today by acknowledging the traditional owners of the ancestral lands in the various locations from which we meet today across Australia, and recognise those traditional owners and their continuing connection to the land, waters and culture. We pay respect to elders past and present, acknowledging them as the traditional custodians of knowledge of these lands. You'll notice in the bottom corner of our slides today, there's a barcode which will take you to a Q&A app called Slido. Feel free during the process of today to just add any questions you might have to the Slido, and we will get to those as we move forward. If we can just go to the next slide, please, Ha. The agenda today is pretty straightforward. I'll give you a quick rundown on who Race for 2030 is for those who may not be aware of us. Jenny, who leads our Race for Homes program, will just talk a little bit about that. And then our guest speakers will come along to join us. We're being joined today by Barry Lynham from Canal Energy Solutions, followed by Shona Cleland from the Department of Energy Security and Net Zero, part of the UK government, and followed by Chris Ricketts from Elmhurst Energy in the UK. Once we've heard from our guest speakers, we'll have a Q&A, and then we'll close to get you all away for the night. So thank you again for joining us, and we'll just go to the next slide if we could. Thanks. The Race for 2030, we're a cooperative research centre for energy and carbon transition. Our mission is to lead translation of industry-led research. So we're looking for applied research into innovative, new commercial and economic, social policy and environmental outcomes for the benefit of all Australians. We could move on, please. That'd be great. So we bring together partners from industry, government, supply chain together, and we have more than 120 partners, as you can see there, from all corners of the industry. And in addition to that, we have 9 research partners, including 8 universities and Australia's research entity, which is CSIRO. Together with the federal government, we've got the capacity to do currently as much as $350 million in research over our 10-year life. And that is in cash and in kind. And we are running quite a wide range of projects at the moment in a range of areas. So I might just get you to go to the next slide, Ha. We operate across 5 programs. We have Race for Business, which is looking at helping business move along the pathway to electricity transition. Race for Homes, who we are hosting today for this webinar. Race for EVs, optimising our transport and power use in mobility, and the Race for Networks. And we have a catch-all program called Race for Change, which targets all those things that the other 4 programs don't capture. We have a lot of projects that we're running, large and small, across all of those programs. And if you go to our website, racefor2030.com.au, there's a lot of information there about our projects and how you can get involved if you want to take part in our applied programs. I think that is all I really want to share with you at the moment about Race. It's more important we get on to our speakers. So I'll hand over now to Jenny Gregory, who leads our Race for Homes program, to introduce Race for Homes. Thanks, Jenny.
Great. Thank you very much, Neil. So the Race for Homes, our overarching driver is to reduce emissions and energy bills at scale across the residential sector. And in the case of homes, if somebody sleeps in a building, it comes under the home remit. So that includes nursing homes, retirement villages and hotels, as well as every kind of home, and every type of ownership of homes, be they social housing, rentals, privately owned, high-rise or not, regional and rural. And we've got 2 main themes: mainstreaming efficient electric homes and engineering smarter homes. And we've got 3 different categories of projects coming in. Some of them are product development. Most of them are projects contributing to the lowering of bills and emissions. And then we've got an increasing number that are looking at demand response initiatives for the residential sector. And across those three pillars, we also have the co-benefits of improving health, comfort, economic wealth, and skills and jobs in the residential sector. And on the next slide, just a bit of a background on our projects. So we've got 3 PhDs in progress. We've completed 11 projects, which are mainly opportunity assessments, which were undertaken in our first 2 years. We've got 9 projects underway and 5 proposals nearing closure. And that's a snapshot of some of them on our website, where you can see the different projects, type of projects that the homes area is undertaking. Thank you. I think it's back to you, Neil.
Yes, thanks, Jenny. So just before I introduce our first speaker, I just want to remind everyone that today's project webinar is being recorded. We'll stop recording when the Q&A session starts. We also have a Slido Q&A app for people to use if they are interested. We might very quickly just go back a slide if we can, just so anyone who wants to be able to scan that barcode, which is down in the bottom right-hand corner there. If you scan that on your phone, you should be able to bring up the question and answer application, where you can enter anonymously or put your name in and enter your questions, and we will work through those as we get to the end of our presentation. So we go to the next slide again. Our first speaker today, and in fact, the one who initiated this webinar, and we're grateful to him for that, is Barry Lynham. Barry's the Managing Director of Knauf Energy Solutions, where he's focused on the low carbon transformation of the building stock. Previously, Barry was the Group Director for Strategy and Communication at Knauf Insulation, where he led their public affairs, regulatory affairs, sustainability, corporate communications, and building science teams, as well as being Secretary of the Board at Knauf Insulation. He has enormous experience in energy efficiency in the home space, and we're really pleased he can be with us today. Thanks for joining us, Barry, and welcome.
Thank you very much, Neil. Thank you, Jenny, also for inviting us, and thank you to Race 2030 for hosting this event. And I think hopefully this will be a good and interesting event to talk about how we make energy efficiency work better. And as the title of my slide says, how do we make energy efficiency more visible? If you want to go to the next slide. So when we look at the challenge of energy efficiency, and we look at it, as I think as Neil mentioned, for quite a long time now, one of the fundamental challenges we think energy efficiency has always had is that the value of energy efficiency has never been visible. So if we compare energy efficiency to power generation, things like wind turbines, solar panels, we always look at those from a performance perspective. So when governments look at things about how do we support those programs, we think about things like contract for differences in the UK or feed-in tariffs to support those programs. And they're always paid by the actual performance that's delivered by the project, how many kilowatts of energy is created, or how much energy is delivered. And that performance-based mentality makes for a very strong market approach, where the market players, the people building those projects, the people running them, are highly incentivized to deliver high quality, to drive down prices over time, and to make for a more efficient system. And we've seen that in solar, we've seen that in wind. Energy efficiency has always been in a very different world. Energy efficiency has always been about, we think it's a good thing, we hope it's a good thing, but we don't really know for sure how much it actually delivers. And so governments have been left having to pay for measures, paying for whether it's a new windows for people, or supporting boiler changes to heat pumps, or whether it's putting insulation into buildings. It's always been a measures approach. And from an economic perspective, that's not a great way to support an industry, because again, it doesn't drive the industry to go towards real performance. It doesn't drive the industry to drive up quality and drive down price. And we've seen that in the energy efficiency world. We haven't seen those massive drops, those massive improvements in the cost of energy efficiency that we've seen in other sectors, like in wind and in solar. And so the question is, how can we do that? How can we move from a world where we base things on measures and hopes and move to a performance-based world? And the fundamental way that, certainly in Europe, we thought about that was, if we could find a way to rate the energy efficiency of buildings, if we could make the energy efficiency visible, and we could then talk about looking at performance we could start using those rating systems to go on performance, we could change the system. And if you want to go next slide, that's what we tried to do with what in Europe we call energy performance certificates. We use the word performance because the whole idea was they were supposed to give performance views. And that idea was a very, very good idea. And it remains a very good idea. But one of the problems we have in energy efficiency is that many of the things we do to a house are not very visible. They're hiding behind the wall, they're in the roof, they're in the floor. And therefore, it's not always very easy to understand exactly the real performance that is being delivered. And that's one of the problems that we've seen with the energy efficiency rating systems that we've rolled out across Europe, is that whilst the idea of having these rating systems is good and is a very important way to start to making this a valuable commodity in the market and making energy efficiency visible, what we've seen is the actual energy efficiency versus the calculated energy efficiency from certificates is often quite far away. And if you could just click through to once there, or this was the purple line shows a house that we studied in Belgium, where the energy certificates that we were looking at were thinking that the house had an energy performance of 687 kilowatts per square meter. And when we measured that house, the real performance was 143 kilowatts per square meter. So a vast difference in the reality versus what the certificates were saying. If you click again, we also looked at a deep retrofitted house, which is the red line. And in this case, the certificates told us that the house was 20 kilowatts per square meter. And when we measured it, we found it to be 220 kilowatts per square meter. So what we were seeing was that whilst the principle of energy efficiency certificates and looking at the rating systems was absolutely critical to make energy efficiency work, the data that we were seeing from our project was showing quite a variation, and not just a variation from always overestimating, but both ways, sometimes overestimating, sometimes underestimating. And if you go to the next slide, we saw the same in the UK when we did new build projects. And here's a new build project where the houses were meant to be quite low energy, which is the gray lines, and that's what the certificates told us. When we measured the homes, we found them 250% more energy demanding in reality than the certificates were telling us. And that was, driven by, when we looked at the houses, it was driven by mostly by poor workmanship. So things that were difficult to be seen by the certificate people going around the house. So it wasn't a fundamental problem with the certificates. It was the difficulty to see the performance, the actual performance going on in the house. And you go to the next slide. This was from the Netherlands, and we kept on seeing this. We kept on seeing very similar things. In this case, again, the houses actually, in reality, often outperformed what we expected them to do. So the left bars are the real performance. The inner bars are the certificate performance pre and post. And what we saw was continually, actually, the real performance in these houses was significantly better than we thought in the Netherlands, than the certificates were saying. And that was really important to the customer, because it meant that to get heat pumps into those houses, we weren't going to have to do a second series of activities. We could actually stop at that first retrofit position. And so it shows you, but across different countries that we've been looking at in Europe and across different certification schemes and against different projects in those countries, what we see are these variations between the real performance and what the certificates tell us. And so we see this big gap between theory and performance. And again, it's really clear that I'm not saying that we should throw the baby out with the bathwater. The idea of certification is critical. It's absolutely really important to create that value position in the market so that people understand the performance of energy efficiency, and we can move away from a world of paying for measures and paying for performance. And when we started certificates, the technologies didn't exist to make that better. We didn't have better technologies. We didn't have the IoT. We didn't have other approaches. And in fact, when we started this work and we started doing certificates 10, 15 years ago in Europe, the only way to really understand the real performance of a house was to do something called a co-heating test, which was an academic study where you would empty a house for 3 weeks of the people living in it. You would keep it at 25 degrees heating for those 3 weeks, constant. You would stick thermocouple through the walls. You would measure the measured temperature and humidity across the entire house. You would trace your gas tests. It was a very expensive 15,000 euros per house study to understand the performance of the house. And you can imagine we're not going to do a 5,000 euro retrofit and then pay 15,000 to check whether it was done correctly. That just wouldn't work. So the question that we took as a company was, well, we really wanted to show at the time as an insulation company, when I was product enough insulation, that insulation really worked, and that energy efficiency really does work. And so we decided to say, is there a way to solve the problem with new information technologies where we could know the real performance, right? Where we could understand exactly the performance of the house, and we could make certification what it was meant to be, a very accurate performance view of the house in reality, so we can move energy efficiency to a world of performance space, help regulators to actually get what they pay for, to make sure people living in houses get the new homes they paid for, get the energy efficiency retrofits that they paid for. And that's what we looked at. And if you go to the next slide, the way we did that was we started by developing the ability to acquire data in homes with very cheap and easy to install sensors. I won't go into the detail, but we take things like indoor temperature, humidity sensors. We obviously take energy data from the homes. But the important thing, and if you go to the next slide, is we couple that acquisition of data with machine learning, and we develop and we create really strong insights. And I don't think we have time today to go into exactly how we do that, but the fundamental thing that we do, and that's the graph on the left, is we train the algorithm on the energy data of the home and the home's data on things like temperature, outdoor temperature, and indoor temperature for a period before retrofit. And that's the gray box before, on the gray area before the line is just the energy being used. And we check the algorithm's efficiency of understanding the house by checking its ability to guess the energy data and the energy and the heat data going to the house day after day after day. And that's the red line. And as you can see, the algorithms are very, very accurate at predicting energy use in the house. And that allows us to then clean out all the human behavior and clean out all the weather behavior to get a real energy performance certificate view of the house pre and post. We've been calling it an energy demand indicator on the right, but it's just a real energy performance certificate or a real energy rating system for the house, where we strip out human behavior and other behaviors, and we get this true view of the house pre and post. And that's the fundamental kind of thing that we try to do. And it's, again, it's not a very, it's rather complex in terms of math, but from an idea perspective, it's not very complex. All we're doing is trying to make sure that energy rating systems, energy performance systems, give an accurate view of the actual thermal efficiency of the house itself, the fabric itself, and the energy systems of the house, so that we give people and regulators that core data to understand how we actually improve buildings, how we actually delivered the savings that we expected to deliver. If we go to the next slide, of course, the next thing we had to do is prove the accuracy, and we've been working with people like the Energy Systems Catapult in the UK to show that we're accurate, and you can see our accuracy is very high. There are other people in the market who also offer these kind of services, but obviously, if you're going to go and say the important thing is to go towards an accurate view, you have to be able to demonstrate that you're accurate over time and that you can deliver a very high level of accuracy. We're plus or minus 5% accurate in terms of the way that we do it, and that's important. And you go to the next slide. The next thing you have to do is you have to think about how do you then incorporate these into different systems that already exist. We're not sitting here saying you need to throw away, for example, the energy performance certificates in the UK or across Europe. No. All we're saying is that we need to integrate the real performance data into those certificates to make sure they deliver what we always wanted them to deliver, which was a highly accurate view of the performance of houses, so we can value energy efficiency and we can make energy efficiency work correctly. And Chris will talk much more about that than I will, so I'll stop here. I won't talk about how those things are being integrated and how we can do, but there are ways to integrate that kind of data into the existing systems to make them work. We're also talking with government about how to integrate them into government programs so that programs can move away from paying for measures and paying for energy efficiency improvements, letting industry decide themselves how best to make those houses more efficient, and actually allowing the market to do its job. And that's the first big program that we're looking at. And we're hoping the UK will come out soon, is what's called the Energy Company Obligation Program, which for the first time will be a pay for performance program based on these new approaches to real performance. And so, again, as I say, it's absolutely critical. I think that going towards rating systems is absolutely essential to make sure energy efficiency can play its proper role within the energy system. Making them accurate is now possible. And I think Australia, as you look to think about how you move to this new world, you don't have to play catch up with Europe, because actually we're having to now integrate these systems. You could go straight to these kind of approaches from day one to have real performance kind of underlying and really getting the full benefits of certification and rating systems that we're only starting to get now in Europe and the UK. Thanks very much.
Thank you, Barry. That was, excuse me, that was really interesting. I think it's endlessly exciting the way technology is bringing new opportunity to the age-old challenge of energy efficiency. So thank you for sharing, and we appreciate you spending time with us, and we look forward to the Q&A with you. Our next speaker is Shona Fallon from the UK. Shona is Head of Policy and Implementation at Smart Meter Enabled Thermal Efficiency Ratings team, known as SMETA, which are part of Department of Energy Security and Net Zero within the UK government. Shona leads all policy development for new methods of measuring energy performance of homes in the UK and has been doing a lot of work in this space of recent times. So we're really pleased that you can be with us today, Shona, and we look forward to what you've got to say. Thank you.
Great. Thanks very much, Neil, and thanks, Jenny and Ha, for organising this and putting it on. So just building on what Barry has already set out really clearly about the value of in-use measurement approaches, I just wanted to talk a little bit about the UK government journey that we're on in this space. Like many countries, as Barry has explained, the UK government has established an energy performance of buildings assessment system that relies on visual checks of homes, combined with kind of models that tell you about the average home or the typical home based on its characteristics. But lots of homes aren't typical. You often can't tell by looking at them how well they were constructed, what insulation materials were used, whether they were well installed, whether there's cold air coming up through the party wall, all sorts of potential variation in homes, which you can't fully understand without directly measuring the building. And that's what leads to the performance gap, which Barry has outlined between the assessed performance of a building and the measured performance of the building. So when these measurement methods started to emerge from academia and from industry, we were really interested in the potential there for better understanding how individual buildings perform rather than how they perform on average, and the policy solutions that can offer at a national level. So that's why we got involved. If you could move on to the next slide, please. Thank you. So I just want to pause and note the terminology before we move on, and talk a little bit about the concept of in-use measurement, just building on what on Barry's excellent explanation that he's already given us. So from the UK government perspective, we were coming at this from the smart metering programme. That's a part of government that I'm embedded in. So the way that we were looking at this was, how can we leverage the smart meter rollout for maximum benefit, get all the opportunities that we can out of it. We've been rolling out smart gas and electricity meters across Great Britain, and that provides kind of opportunities to access data on energy consumption that we didn't have before at scale. So that's how we ended up with this horrible acronym, which I'm sure nobody else uses except deep within UK government. But it's hard to break these habits, isn't it? But that's what SMETA is, Smart Meter Enabled Thermal Efficiency Ratings. So it's just an umbrella term, really, that we use for these innovative technologies and methods that measure the thermal performance of buildings while in use. By in use, we just mean occupied by the householder. So we also say things like in situ measurement within kind of industry in the sector. I mean, that matters because it makes these technologies a lot more scalable and a lot less disruptive to the people living in those homes. They don't have to move out for 3 weeks or even overnight while you conduct tests on their home. You just take these measurements while they're just living their normal lives. So you can produce a variety of metrics with these technologies and algorithms. We've been really focused in UK government on uses of the heat transfer coefficient in particular, which is just the average rate at which buildings lose heat. But you can learn all sorts of things about buildings. And the data inputs, as Barry touched on, I mean, they differ depending on the particular method and a SMETA provider, but essentially you use energy consumption data coupled with other low-cost scalable data sources, things like weather data, so that you have external temperature data, usually internal temperature data from, well, the gold standard would be from temperature sensors placed throughout the home. But you can also get some really useful information just from a single temperature sensor in a smart thermostat, for example, other technologies that are already placed within the home. And some use other information as well. So Canalf, I know, uses heat meters. Some of the technologies in Britain just use the gas consumption data, which is, we mostly use gas for heating homes within the UK. So gas consumption is a pretty good proxy for the energy that you're using to heat your home. If you can make some, clever assumptions about hot water heating as well. I think in Australia you use a kind of wider range of heating methods more commonly. So other ways of understanding the energy use for heating the home in particular, like a heat meter, might be more necessary in Australia. So we can move on to the next slide. So, I mean, I suppose for everyone on this call, it's probably quite obvious why we're interested in this, why it matters. We're not alone as a country in having really big ambitions for achieving net zero greenhouse gas emissions, and we've got new ministers in the UK. We've recently had a change of government, and they are ambitious. They want to make progress on this goal as quickly as possible. And energy performance of buildings and how homes are heated in particular is at the heart of this. We need to make absolutely huge strides in the next 10 years if we're going to stay on track to meeting our goals. And the more and the better information we can use to inform decisions about how we do this, the quicker and the more efficiently we can make progress. And that's at the level of policymakers, at the level of kind of government solutions for this, but also for industry, for installers, energy suppliers, and at the individual household level. We're all kind of making decisions about which houses to target, what measures to install, which buildings are ready for heat pumps and which aren't. And if we can spend that money more intelligently, because we have better information to base those decisions on, kind of all the better, And there's a huge range of potential applications for these methods. I mean, retrofit is the obvious one, heat pump readiness, heat pump sizing, but also things like unlocking green finance, giving a bit more assurance to banks and other green finance providers to encourage them to lend money for green mortgages and other kind of green finance products, because they know more about the building on which they're lending money and what the return on investment might be. You can better target support with that information. You can identify households that are at greatest risk of fuel poverty or health risks, overheating and underheating. You can identify hidden issues in the housing stock. So the point I mentioned earlier about cold air coming up through party walls, that's something that we might not know about if we didn't have measurement methods to tell you kind of which types of houses are suffering issues that we didn't know about before. You can introduce things like outcome-based incentives and obligations on industry players. So there's all sorts you can do with this. And in a way, we're kind of victim of the myriad opportunities there are in this field, and having to narrow down what to focus on in the short term while we make progress on this. So if you could flip over to the next slide, please. I just want to talk a little bit about where we come from and what we're doing and where we're headed in UK government on this. So we kicked off our investment in use measurement methods in the UK with the SMETA competition, which supported the development and testing of SMETA methods in the UK, and followed this up with trials to kind of evaluate and demonstrate their performance. So that was based on 30 fairly typical homes within the UK, on which we also conducted co-heating tests so that we could compare the different SMETA methods that were involved in this innovation programme with, you know, the closest we could get to the ground truth using co-heating tests.
I think we've lost Shona, have we?
Of this.
Oh, Shona, are you back with us?
Yeah, I think we've lost her.
Oh, yes, we've lost her. Oh, she's come back in.
Can you hear me again?
Yes, we can.
Okay. I was just the results of our evaluation of SMETA methods showed that the ones that performed best were those that had internal temperature data. More recently, we've been doing some interesting work on potential applications for those slightly less accurate but incredibly scalable methods that don't use internal temperature data. Because if you take a bigger sample of 50 or 100 homes, then they become more accurate. So you can use that information to understand property archetypes better, for example. But really, what we found is for understanding individual homes, individual buildings well, you kind of need that data source. And off the back of that, we moved to understanding a bit more about the highest potential applications of these methods, and started working with policy and innovation teams within government to embed SMETA methods in various kind of policies and projects as a test bed, essentially, to learn and build from. So that includes innovation programs on heat pump deployment and unlocking green finance to drive the uptake of energy efficiency measures. There's a handful of projects in both of those programs that use SMETA methods in various different ways. So they're kind of, for the most part, in the delivery phase. We're just starting to get learning from some of them. One of the ones on heat pump sizing has already produced a really compelling report. I won't talk about that too much because that was the one that you were involved with, Chris. I don't know if you intend to touch on that, but if not, we could always pick it up in the Q&A, because that has had some really interesting findings on the vastly different outcomes that you can get when you size heat pumps using measurement rather than assessment-based approaches. And we're also embedding in-use measurement techniques on a relatively small scale for now, but hopefully growing in some of our energy efficiency schemes. So what was then called the Social Housing Decarbonisation Fund, now it's Warm Homes Social Housing Fund, has had a wave with a digitalisation uplift, which supported the installation of energy performance measures in social homes in particular, and offered an uplift in funding to a limited number of housing providers to use digital techniques to improve their housing stock. So I think we'll learn some really interesting things from social housing landlords who are using these measurement techniques to kind of understand and target their housing stock with that funding. And as Barry mentioned, our colleagues who work on eco and GB insulation scheme programs, which are essentially energy supplier obligations to install energy efficiency measures, are hopefully soon to be consulting on a policy pilot which rewards energy suppliers for actual energy efficiency gains rather than simply activity. And you can see how that has the potential to really drive better quality outcomes and materials, and to target all sorts of measures which perhaps weren't rewarded under the scheme, the wider scheme. What you guys have been thinking about, who are on this call at the moment, is how this stuff might interact with the energy performance of building system, with the assessment system. I mean, this is a big and complex question for us because it's a very established system that's used in a lot of ways across the UK, by government policies and programs and by all sorts of people within the sector. So thinking about how you would use measurement to support or improve that system is a really big question. EPCs do something quite different to measurement because they come at the question of home performance from an individual, from the perspective of individual elements of the house and make recommendations based on those elements, whereas in-use measurement methods tell you about the fabric of the whole home. So there's lots to work through there, but also huge potential to make a really big difference. So we have work streams on the EPC action plan, particularly looking at existing homes and our future homes, and building standards that are considering how in-use measurement might improve and support those systems. But I think probably a little way to go before we're ready to kind of integrate, I suppose. And then there's what we're working on our team, which is kind of further developing and implementing these methods across government on an iterative basis, I would say. So we're still thinking about our evidence base, seeing where the gaps are and reinforcing that where we need to, thinking about what quality assurance might look like in the space, how we think about accuracy criteria and make sure that what we're doing kind of meets standards within government for accuracy for the different contexts in which you might want to use it, and developing some of these applications and use cases of in-use HTC in particular. So that's the rate of heat loss. So more to follow on all of that. For anyone who's interested, happy to stay in touch with any participants today who want to know more as we develop this work. But yeah, as I said at the beginning, we're on something of a journey in the UK. There's a long way still to go before we fully understand how to make best use of these technologies, but lots of potential here. And potentially in Australia as well, as you're thinking about the design of some of these systems, whereas in the UK we're working with established systems in various ways. I mean, I know that you've got a lot going on in Australia and lots of really interesting established systems as well, but also thinking about what you might do that's new. So there's potentially lots of opportunity here. So that's it for me. I think the next slide will probably be for Chris.
Thanks, Shona. That was very, very interesting. I think it's really interesting to hear you talk about taking a whole of system approach. I heard someone talk about the exact thing during the week already, suggesting that if you went out and got the highest performance cars in the world and you took the best of the braking systems, the best of the accelerating systems, the best of the cornering systems, and the best maneuverability out of those 4 cars and put them into one car, you wouldn't have much of a car at all. What you really need is something that works all together to deliver the best, and that's where you get the most. And certainly at a race level, we're looking at whole of energy system and how we can make a difference. So thanks for that. Our next speaker is Chris Rickett. So Chris is head of consultancy at Elmhurst Energy, and Chris has got more than 4 decades of experience in energy efficiency consulting, commercial project management, building services, and building transformation. He plays a key role as head of consultancy at Elmhurst Energy Consulting, helping clients reduce their carbon emissions to net zero by 2050. He has extensive experience in managing market transformation and legislative change and ensuring that clients adapt to evolving landscapes of energy efficiency. For this role, Chris held significant positions at BSS Group and Travis Perkins, where they led major transformation projects, streamlined supply chains, and drove business growth through strategic category management and commercial innovation. He's known for his consultative approach, strong leadership, and fostering inclusivity. Chris has consistently delivered exceptional results in really challenging environments. So welcome, Chris. We look forward to hearing from you.
Thank you, and thank you very much for this opportunity. And I'm listening to all of this, and of course it makes sense to me, but I realise we are throwing a lot at our participants. There's lots of, words that we're using perhaps that don't necessarily meet up with sort of like the context that everybody's understanding. So I'm hoping the Q&A will probably sort of like try and sort of weave out some of the sort of understanding, because it's about trying to connect the dots, really. That's what I want to try and do with the sort of next bit that I can do. I just want to position where we are. So obviously Barry and Knauf, for a start, they provide products that we're in construction that help for energy measures and improvement. They have an ability to be able to got the technology to be able to understand the performance of a building. Showing talking obviously from a governmental point of view, that's the regulatory landscape, where do we work, how does that work, the funding mechanisms, etc. Where we sit as Elmhurst Energy, so part of a group, we're the UK's largest independent provider of energy assessments. We do retrofit and property professional sort of training. We provide software for carrying out these energy assessments, and we do accreditation. And I know you have accreditation organisations in Australia. So we have circa 15,000 members, probably 10,000 of those operating in that sort of domestic sector. So they're lodging new build, so that would be your sort of NatHERS sort of energy rating sort of certificate. So we call that an EPC. So they have new build and existing dwellings. So we do both. So we've got what we call on construction, that's your new build, and existing dwellings. We use a one called RD SAP, reduced data SAP, and I'll come to that in a little bit more. Most of the people that are actually operating and carrying out those property surveys using the software and producing outputs are self-employed. They are one man, woman sort of organizations up and down the country, providing that for estate agents, surveyors, directly with sort of governments, social housing, lots of different sort of customer base. Next slide, please, Har. So just to sort of position this, so as I said, we have existing dwellings and we have new build. So existing dwellings, that's what we would call a domestic energy assessor, a DEA, and they will go to a property, and this is a visual inspection. This is where we will carry out our training. It's at least a week's worth of training, and they will carry out an assessment on that property. That could be a house, a flat, apartments, bungalows, whatever it might be. We even park homes. And they will go to site, they collect a set of data, and they will put that into software, and that software will then produce a legal certificate at the end of it, an energy performance certificate. The new build sector, that's very much desk-based. So you have a set of drawings, you will have specifications and plans, and that data is then equally put into some software. And that software is called SAP. And I'll come on to that in a minute. But essentially, both of those using that methodology, that SAP methodology, gives then a breakdown of that property's energy performance, and it's a prediction. It's got some standardization in it to be able to compare and contrast lots of different buildings. So it defines what the internal temperature will be. So that's a standard for the type of activity that goes on it. It's got weather profiles for depending where its location is in the country, but it does standardize sort of occupancy and sort of usage of cooking and heating and things like that, just so that and this is what, when you measure real time, that's how you find sort of variances occurring, your sort of performance gap. And then we have an environmental impact, your CO2 emissions, and our EPCs also produce a set of recommendations for improvement. So you get your property, you understand where it is today, and what are recommendations based on a sequence and the priorities of sort of costs and biggest improvement opportunity around it. And there's an estimated sort of energy use along with potential savings if you make those recommendations. Next slide, please, Huh? So in the UK, we've got this standard assessment procedure, this SAP. So that's the and it's a 191-page document. And essentially, I think that would probably equate to your NatHERS. It's a national calculation methodology. It's for dwellings. It allows you to, if you were doing this as a new build, you can put in calculated U values for construction elements within it. You can put in air tightness, and that improves your calculation figure. And as part of that calculation, and I'll come on to that in the next slide or so, there is this heat transfer coefficient, this HTC. This is a figure, and that is your sort of thermal performance of your building, and it's built up of the heat losses of your fabric, your air infiltration and ventilation, thermal bridges, and it's part of your energy assessment. The result of using that methodology is this EPC certificate. This is this legal certificate we have, and this is where I said, you know, it has this rating score and a banding, and Barry showed that in his slides. You know, this F to A, an A plus, estimated number of CO2 emissions, annual consumptions, and elements like that. Next slide, please. In that calculation, so that specification of how that methodology works, that the first part of it is sort of like looking at your what's my area and the U values of my property. That's the heat transfer between the internal surface and the external surface based on internal temperature and external temperatures, and you calculate all those heat loss of all of those components. You calculate a heat loss that's been for air transfer, that's either done by infiltration, you know, area infiltration, and the sum of all of those then comes into a HTC, which is field 39 in the first part of the sort of software set of calculations, and the standard doesn't allow you to override that currently. So for a legal document, there's only a certain number of data fields you're allowed to do. In the UK, we can measure air infiltration, and we're allowed to add that into the software calculation and update the legal certificate. U values, you can calculate those. We're not allowed to measure those at the moment on site and be able to put those in. These are all the sort of development work that we're all looking at the moment, is in situ measurements and being able to update the prediction model. So our software that you have, we've adapted that. So as part of some of these suite of programs and development work and sort of research that we get involved with, we've then taken the standard software that we can use and adapted fields so that we can override it. So we can use that then to produce sort of outputs. So it uses the same calculation methodology. It's got this HTC, so we're allowed to override it. So we literally jump into the calculation. We've measured it, may have calculated it to be 105. We've measured it and it actually turns out to be 120. We'd put that in and it produces the same set of outputs. So it's, you know, that's the important bit. It makes it then directly comparable to the prediction versus your measurement, and that allows you to then work out your performance gap. And the HTC is a great measure because it tells you the firm performance of the building. You can then follow that with a number of diagnostics. You can go and do air tests. You can do U value measurements. You can do thermal bridge calculations, and you can start to work out where within that building is this, you know, extra, you know, heat loss occurring. Is it through the fabric? Is it through cracks, and is it through ventilation? You know, and you're trying to determine where that's through. Next slide, please. So in situ measurements. So buildings, as we've just been saying, you know, you can see them side by side and you think most buildings, that building's the same as that building, should be performing the same, but you get this unexpected performance. And unexpected performance obviously has unintended consequences associated with it. So they tend to be, you know, extra energy losses, you get thermal comfort issues, you might have poor ventilation that leads you to damp and mold, you know, and so the whole point of being able to measure and be able to put this back into methodologies means that you can measure what's going on, and then you can start to manage things, so you can better target and prioritize sort of retrofit activities, as we sort of intimated earlier on. You can actually use that to inform retrofit design and specification. Barry was talking about that earlier on. You know, you think you've got to a position and actually you're better than you thought, and that allows you then to say, well, actually I don't need to make those additional fabric improvements. I can now have a very efficiently sized heat pump installation done from this point onwards. But it allows you also to do quality checks and verify as built performance, you know, and gives you that whole feedback and inform sort of future projects. And that's very much within that sort of retrofit sort of world. And we have the ability to be able to measure that. We have the tools and the techniques, so we can measure heat losses. Barry's obviously is the Canal for Energy solution system allows you to be able to do that. We can do air tightness. We have blower door. You have blower door, I believe, in Australia. We also have another system, a low pressure system called Pulse, which we can use in the UK. We've got systems for measuring U values. Barry was talking about the expensive sort of like heating a house up to 25 degrees. There are U values you can do, which heat flux plates, that takes about a 3-4 day period of time. But now we're looking at mechanisms where you use thermal imagery, and that's this heat 3D solution. And obviously you've got standards sort of like ventilation flow rates from hoods, etc. So all of that detail, all of that information can be got and put back into these models and improve your models so you have a better understanding how they're building. Next slide, please. So, you know, as I said, you know, we've got assessment methods, we've got testing methods, we've got competency schemes existing in the UK. So we you know, people know how to deliver these. They've got assurance, they've got governance, they've got surveillance and audit trails behind them. We've got the ability then to measure all of those, and that's where then we got key stakeholders from government departments like DESNZ, Ofgem, who manage our sort of the energy obligation side of things, and they want confidence that this is all a joined up, you know, and there is no opportunity really for sort of failures to happen. So, you know, the checks and balances are being done through that, and that's where we put a focus on. So we're at the pointy end of the stick, you know, so we focus on getting the schemes, getting the competencies, doing the training, becoming agnostic of sort of technology, but we want to make sure that it all joins up properly and delivers a repeatable, scalable, competitive outcome at each point. Next slide, please. Just as and Shona sort of mentioned this bit. So there was a bit of work that we've done sort of measuring HTCs. So obviously that is a methodology for calculating a heat loss within a building, and there are other standards for measuring heat loss within buildings. There's a British standard, BS 12831, and we've done measurements of those and tried to compare, does this methodology of SAP equate to a heat loss calculation, which is used for heat pumps? And if we do a measurement of a building, you know, how does that correlate within there? And there are lots of different discrepancies for several different reasons that the calculation approaches may be different. But this was a bit of work that was done by another organisation called NG Saving Trust, and they looked at like 500 plus homes. And in the SAP methodology, you're obviously calculating your HTC, and you know, we were trying to see whether, when we went to measure these buildings, how different they were. You know, were they oversized, undersized, and could that be used then for heat loss calculations and then heat pump calculations? And we find that, you know, there is a very good correlation, and you do get some certain outliers, and this is a topic in its own right, and you'll disappear down very many sort of rabbit holes. But what you do find is that, you know, of those 500 homes, 72% of them had less heat loss than expected. So actually they were performing better, and therefore we could target our approach to how we might want to carry out their retrofit standards or sizing heating systems, and therefore understanding its impact on our national grid as a consequence of the electrification, etc. So there is lots of work. So there's a reason why you should measure, because it helps inform you a little bit more. You know, the whole point about these models is to keep adding to the data. And I know we have a huge amount, you know, got over 24 million EPC bits of data across our sort of like portfolio of the housing stock. So it gives us a very informed picture. Next slide, please. But the opportunity from all of this really is pretty much what I'm just saying here is, you know, we can model buildings, we can go and measure buildings. That allows us then to appraise those retrofit options, you know. So you know, if I'm a social housing provider, and this is where our social housing decarbonisation fund is a funding mechanism that allows them to approach and, you know, do some baselining and determine what their improvement plans should be and what is the best return on their investments. You know, we've got certain sort of like, we have private landlords as well, you know, with they've got sort of like housing stock, and by measuring, it allows them to actually understand how their buildings are performing. And we have some very old aging stock, and sometimes we're making some expensive decisions that might not necessarily be the best route for that. There might be some intermediate sort of standards that could be done. By measuring, you can find out a little bit more. As I said previously, we've been using this opportunity to see whether we can size heat pumps better. And as sizing and heat pump, we're in the gas boiler world, which is very much on off, and oversizing really doesn't make too much of a problem to you. But as soon as you come to an heat pump, you want that to be sized correctly. You want its efficiency to be right. You don't want that you know, switching on and off and having high impact rates on its efficiency. So there's an upfront capital cost, but there's also an ongoing efficiency running cost associated with it. So heat pump readiness and that, can we size better, you know, but using measurement is one way. And Barry pointed it out earlier on, you know, with the validating improvement. So we're using government money a lot of the time on these deep retrofits, and are we getting the intended design outcomes? You know, this allows us to validate, and that feeds into this sort of pay for performance sort of model. You know, so yes, people can come up with innovative ways of improving retrofits and actually measure their outcomes and actually be rewarded for making some of those sort of like pioneering sort of approaches. So checks and balances it allows us to do. We've got lots of compliance work. We have in our POE, that's post occupancy evaluation. You know, are the buildings, we've got new build developers looking at using this measurement to understand over a 3-year period, is that building and the sustainability that they thought with their low carb technology meeting the requirements for the residents. And past 2035 is a retrofit standard. L&F, there are standards for energy consumption in new build, and 40101 is a building performance evaluation. So these are all standards we're using, and we're trying to put that in. So that's the end of me. Next slide. Just say thank you.
Thank you, Chris. Thank you, all our speakers tonight. It's been just wonderful, really, really interesting. Unfortunately, we've just hit our stops, and I can share with you that we haven't had any questions through on Slido yet, and I think that's as much to do with the fact that the conversation and the presentations have been so engaging, and there's just been so much good information coming through. We just haven't had time to turn to them yet. So what we're going to do is we're going to leave the Slido open until lunchtime tomorrow, at which time we'll collect the questions that have come through. And we had about half a dozen questions posed to us in the lead up to this, so we'll answer those as well, and we'll work with the speakers to answer all those questions and share those. It may take a bit longer to get back to them unless they're willing to get up in the middle of the night and answer those questions, but we'll see how we go. But in closing, I just wanted to share with you how I saw today. I thought this was just some incredible presentation here. You know, for those of us who've been in this industry for a long time and seen all of the potential for energy efficiency, all of the innovation that's come over the last 30 years, but really, you know, it just hasn't quite got there yet for a range of reasons. And what I really saw today was technology finally catching up with our ambitions for energy efficiency. You know, the ability to get real data in real time that's reliable, couple that with generative AI, machine learning, with large language models to make it more accessible. It just opens up new opportunities for things like visualization, for unlocking funding, green funding, unlocking funding, green finance, unlocking funding from governments with a level of confidence that they know that their money is being spent effectively, and that they can target not just the key challenges, but we can find hidden issues. You know, that whole issue of within the housing stock of finding heat loss through party walls, you know, that would never, you know, one day that was going to be uncovered, and finally we've got to the point where we can start to find things exactly like that, which, you know, augurs well for the future of our built environment. And I think when we look at some of the incredible measurements that we're making, really, you know, it shows us that we're really starting to get on the right track. And there's a real opportunity now to value energy efficiency, which provide confidence to network operators to lock it in, provide confidence to governments to incentivize it, provide confidence to policymakers to challenge, to drive more energy efficiency. And we always talk about the cheapest energy saving is the energy we don't use, but you know, that's often been a bit of an elusive target. But now we're getting close to being able to say, no, we can measure that, we can point to that. Of course, one of the big messages here is we still need the resources to deliver this and conduct the compliance that proves that it's there, and that's important. We need that capacity. We need to work on that. But this has been, for me, a real eye-opener. I think the work that's being done in the UK is just incredible. And I really, again, want to thank our speakers, Barry, Jonah and Chris. It's early. You've got your whole day ahead of you, but there's a lot of people here who've stuck with us till after, in some places, 6 o'clock at night. School holidays over here, so some of them have got to get home. They'll have screaming kids, I'm sure, that need to be fed. We appreciate all of you who have joined us today, and we'll be in touch with more information from today. So thank you all for being part of this. For me, it's been highly valuable, and I hope you've gotten something out of this as well. So thank you.
Yeah, I think it's exciting. I mean, good luck to you all. Yeah.
Thank you. Thank you for taking the time to share with us.
Thank you.
Thank you so much.